Good morning to all. This is Wahida, working as an assistant professor in ECE department in CHEBROLU Engineering College. Today I am going to discussing about microprogrammed control. The microprogrammed control is used to generate the control signals inside a processor. So already we know the control signals are required inside the processor. These control signals are generated by using two ways. The first one is hardwired control. Already we discussed in previous lectures about hardwired control, how it generates the control signals. Okay, so in there we used a control step counter. Okay, so in that hardwired control unit, the control signals can be generated using a control step counter and a decoder or encoder circuit. And now we discuss an alternative scheme which is called microprogrammed control. This is the second way for generating control signals inside the processor. Okay, so in microprogrammed control, the control signals are generated by a program similar to machine language programs. Okay, so this microprogrammed control generates the control signals which are generated by a program similar to a machine instruction programs. So before going into the microprogrammed control, first we have to know some terms. Okay, so first we have to learn some different terms. The first one is control word. Control word is a word whose individual bits represent the various control signals. Okay, so control word is a word whose individual bits. Okay, so control word contains the bits. Okay, so the individual bits represent the various control signals. Each of the control step in the control sequence of an instruction defines a unique combination of ones and zeros in the code word. For example, consider this example. Okay, so now we will write see the code word corresponding to the step 4. Okay, so code word is a word whose individual bits represents the various control signal. Okay, so now we are going to writing a code word corresponding to this step 7. Okay, so in step 7, what control signals are activated? Z out, R in and end. Okay, so Z out control signal, R1 in control signal and end signal. These three are activated. Okay, so now we have to write a code word for the step 7. See, So this is a microprogram instructions. See, in case of for 7th micro instruction, what control signals are activated? In our example, we are activated Z out control signal, R1 in and end. So Z out control signal is activated. Here we are represented as 1 and R1 in is 1 and end signal is 1. And the remaining all control signals will be 0. See, Amma, here also y in is 0, place 0. Okay. So, except Z out, R1 in, end control signal, the remaining all are 0. So, this is the code word. Okay. So, code word is word whose individual bits represents the various control signals. So like this way we will write the code. Suppose in case of first instruction, so what signals are activated? PC out, MER in, read, select 4, add, Z in. Okay. So for writing code word for these first micro instruction, we have to activate those control signals: PC out, MER in, read, add, Z in. And the remaining control signals will be 0. So this is a code word for the first micro instruction. Okay. So like this way. So for the 7 micro instructions, we have written here 7 code words. So now by using microprogrammed control unit, we are going to generate these code words. Okay. From these code words, the processor will activate the corresponding control signals. Okay. From these code words, the processor will activate the corresponding control signals, and a sequence of code words corresponding to the control sequence of a mission instruction constitute the micro routine for that instruction. A sequence of code words corresponding to the control sequence of mission instruction constitute the micro routine for that instruction, and the individual control words in this micro routine are referred as micro instructions. Okay. So you learned 3 different terms: code word, micro routine and micro instructions. And next, the micro routines for all instructions in the instruction set of a computer are stored in a special memory. Okay. So all these micro routines, okay, all the micro routines for all instructions in the instruction set of a computer are going to be stored in a special memory. That special memory is called the control store. Okay. So here this control store will stores the micro routines for all the instructions which are in instruction set of a computer. Okay, this is the control store. The control unit can generate the control signals for any instruction by sequentially reading the control words of the corresponding micro routine for the control store. So what this control unit do? The control unit generate the control signals. Okay, so it generates control signals for any instruction by sequentially reading the code words of the corresponding micro routine from the control store. Okay, this suggests organizing the control unit, which has shown in this figure. So this control unit or control store perform this operation. Okay, and next, to read the control word sequentially from the control store, a microprogram counter is used. So this is the microprogram counter. In order to read the control words sequentially from the control store, we are using a microprogram counter. So this is the microprogram counter. Okay, microprogram counter. So every time a new instruction is loaded into the instruction register. So for every time an instruction register will be loaded with a new instructions, means the instruction which is currently being executed is stored in the instruction register. The output of the block labeled as starting address generator. Okay, so next, the output of the block labeled starting address generator is loaded into the microprogram counter. Okay, next, the microprogram counter is then automatically incremented with respect to this clock pulse. Okay, so this microprogram counter is automatically incremented with respect to this clock pulse, causes a successive micro instructions to be read from the control control store or control unit. Okay, so all these will causes the successive micro instructions to be read from the control store. Hence, the control signals are delivered to various parts of the processor in the correct sequence. Hence, from this control store, we will get a sequence of control words. By using these control words, the control signals are delivered to various parts, means various registers of the processor in correct sequence. Okay, and next, one important function of the control unit cannot be implemented by the simple organization of this basic organization of a microprogrammed control unit. This is the situation that arises when control unit is required to check the status of the condition codes or external inputs. Okay, so here we got a situation that is the control unit or the control store is required to check the status of the both condition codes and external inputs. In order to choose between alternative courses of action. In the case of hardwired control, this situation is handled by including an appropriate logic function in the encoder circuit. in case of hardwired control. Okay, now in case of a microprogrammed control, an alternative approach is to use the conditional branch micro instruction. Okay, in order to include both a condition codes and external inputs. In case of microprogrammed control, we are using conditional branch micro instruction. In addition to the branch address, these micro instructions specify which of the external inputs, conditional codes, or possibly bits of the instruction register should be checked as a condition for branching to take place. So here we are using conditional branch micro instructions. Okay, so for this one we have to check the external inputs and conditional codes. They should be checked as a condition for branching to take place. Okay, so suppose if consider this example. Here we are written if branch is less than 0. The instruction branch less than 0 may now be implemented by a micro routine such as, so after loading the instruction into the instruction register, so the first 3 steps from 0 to 2 comes under the fetching phase. After fetching the instruction is stored in the instruction register. Okay, so after loading the instruction register, a branch micro instruction, okay, so the branch micro instruction transfer the control to the corresponding micro routine, which is assumed to start a location of 25th address. 25th address in the control store. This address is the output of the starting address generator block. Okay, so here we are checking the branch instruction. Here we have written if n is equal to 0. Okay, so if n is equal to 0, then the branch to micro instruction 0 means we will back to the 0th address instruction and we will execute this one again. Okay, so if n is not is equal to 0, then we will come to the 26th address instruction. Okay, so means the offset is going to be added to the instruction register out, and next select Y is enabled, next addition will be performed. After addition operation, the result is going to be stored in the Z in. Okay, and next that address is transferred to the program counter by activating Z out control signal. So by activating Z out control signal, the address will be stored in the processor internal bus. By activating PC in, the address is transferred from processor internal bus to the program counter. It gives the end of the execution of these micro instructions. Okay, so the micro instruction at location 25 is going to test the n bit of the condition code. If this bit is equal to 0, A branch take place to the location 0 to fetch a new machine instruction. Otherwise means if n is equal to 1, the micro instruction at the location 26 is executed to put the branch target address into the Z as in step 4. The micro instruction in location 27 loads this address into the program counter. In order to support microprogram branching, so in order to support these type of branching microprograms, the basic microprogrammed control unit, so means this one microprogrammed control unit should be modified like this. Okay, here we are having starting address generator. Now this starting address generator block becomes starting and branch address generator. Okay, so what this block will do, this block loads a new address into the microprogram counter. Okay, so this will loads a new the address of a new micro instruction into the microprogram counter. When a micro instruction instructs it to do so, in order to allow implementation of a conditional branch input to this block, so here we have to provide a conditional branch. So for providing or for implementation of a conditional branch, inputs to this block consists of external inputs and conditional codes as well as the content of instruction register. Okay, so external inputs and conditional codes. Here in this control unit or control store, the microprogrammed counter is incremented every time a new micro instruction is fetched from the microprogram memory. Okay, so the microprogram counter is incremented every time a new micro instruction is fetched from the microprogram memory, except so the except conditions are, so we are having 3 except conditions, so where the microprogram counter will not be incremented. The first one is whenever a new instruction is loaded into the instruction register, the microprogram counter is loaded with starting address of the micro routine for that instruction. Okay, so whenever a new instruction is loaded into the instruction register, the microprogram counter is loaded with the starting address of the micro routine for that instruction. This is the first step. And the second one is when a branch micro instruction is encountered. When a branch micro instruction is encountered and the branch condition is satisfied, then the microprogram counter is loaded with the branch address. When the microprogram counter is loaded with the branch address, when branch micro instruction is encountered and the branch condition is satisfied. Whenever the branch condition is satisfied means, in our example we have written if n is equal to 0. If n is equal to 0 is satisfied, then we will go to the 0th step. See here, whenever the branch instruction is satisfied, if n is equal to 0, then the branch has transferred to the 0th micro instruction. So then here from 25th address we will transfer to the 0th address. So during this situation, the microprogram counter will be loaded with the branch address if this condition is satisfied. So previously the microprogram counter contains the address of 26th, but if this condition is satisfied, the microprogram counter will be updated with the branch address, that is 0th address. Now the microprogram counter will stores the 0th address. And next, third one is when an end micro instruction is encountered. Okay, so, first see, so during a branch condition is satisfied, then so from the control store we will back to the starting and branch address. Okay, so from here now this block will generate the branch address. This branch address will be stored in this microprogram counter. Means the microprogram counter is loaded with the branch address. And next, third one is when an end micro instruction is encountered, the microprogram counter is loaded with the address of the first code word in the micro routine for the instruction fetch cycle. It means as the 0th address in our example. Okay. So whenever an end micro instruction is encountered, the microprogram counter is going to be loaded with the address of first code word. Okay, so it is going to be loaded with the address of the first code word in the micro routine for the instruction fetch cycle. So this is about microprogrammed control unit. So this block will allows both external inputs and conditional codes means it allows the branching, conditional branching. And this block doesn't allow any conditional branching micro instructions. So this is about microprogrammed control unit. Okay, so hardwired control and microprogrammed control units. Both these units or control units are used for generating the control signals which are needed in the proper sequence for the processor. Okay, so in case of hardwired control, the encoder or decoder block will directly generates the control signal depending on the inputs given to that block. But in case of microprogrammed control unit, it instead of generating the control signals, it generates the signals by a program similar to the machine language. Here, depending on the code word, the processor will activate the corresponding control signals depending upon the code word. A code word is nothing but a word or whose individual bits represents the various control signals of the processor. Okay, so this is about hardwired control and microprogrammed control unit. Okay, so now I think all of you understand how the processor will activate and deactivate the control signals. Okay, thank you.